Okay, so these are the section of notes for Unit 1. Key idea here is we're looking kind of at statistics and how to look at numbers. For the first one here, 1, we're going to go through this entire thing together. Alright, so we're going to look at qualitative versus quantitative data. So, qualitative data is data that is what's known as categorical. And not measured. Data that describes things such as colors, smells, tastes, appearance. So again, looking at like favorites. And it can be categorized. That's the key idea here. So whether it's a gender, your education level, how old you are. Over here, so like in terms of freshman, sophomore type things. Quantitative data is data that can be measured. It will involve numbers. So height, area, volume, speed, anything you could find the average of. What you guys could complete here, we could look at this and maybe think of some qualitative and quantitative. So qualitative could be like the color it is, there's a heart on top, you know, so those visual type things that we can't really measure. Quantitative could be like how much coffee's in there. So again, at this point, I'm just kind of getting those big two vocab words, that qualitative versus quantitative down path. Again, you'll hear me use the terms qualitative and categorical kind of interchangeably. I usually stick to categorical just because, again, it's the idea of buckets or categories we fill. Where finding the average or the mean wouldn't really make sense. Alright, now we're on to number 2. So another section of notes here. We'll be completing the majority of these problems together in the video. Alright, so we're looking at some shapes of distributions. So we will define the 3 shapes of data distributions here. So for our warm-up, we're going to consider the height of students in the class. If we were going to go ahead and do this activity, we can kind of graph everything and then see the different shape it takes. But let's move on down here. So, our 3 big ideas here are skewed and normal. So skewed to the left, if we draw kind of a hill here, most of the data is on the right. So skewed left means all of our data is on the right. Symmetric means kind of, it's all in the middle. It almost looks like a hill shape. Skewed to the right. So skewed to the right puts our data here on the left. So those for the skews, kind of think backwards. Okay, so first thing we're going to do here is you're going to need to open up Algebra. So to do that, here's what you're going to do. In the bottom left corner kind of your thing here, you'll see this little box. You might have a bar here that says Cortana, Ask Me Anything. If you just click there and you start typing Algebra, spelled just like I did here, it'll pop up here. So go ahead and open that up now. This is something we're going to use a ton of in this class. It's a great system to help us solve our equations. So give me a second here, kind of adjust my screen. Alright, so here's our GeoGebra. In order to get the windows how we want them, what you're going to do down here is click View. You want to make sure that we have the following things highlighted. So we're going to go to View. You want Algebra with a blue box, Spreadsheet with a blue box, and then our last one is going to be that Graphics. So once you get it, you should have all these things highlighted. So Algebra, Spreadsheet, Graphics, and then our input bar. Give me a second here. Mine's not quite showing up how I want it to. So let me play with mine a little bit here and see if I can make it look how I want. Let's see if I do this. So the graphics. There we go. So my algebra is kind of off to the left. Yours might be in a little bit of a different order. That's fine. You can kind of drag and drop here, make these things about the same size for each one. Alright. So again, those views here, Algebra, Spreadsheet, and Graphics. And the input bar is already selected. One other thing you're going to want to do here to set this up is go to Options. And we are going to go, actually I lied, go to View, go to Layout. So to make yours look exactly like mine, first thing you want to make sure this box says Show. And then yours will be here. I want you to go ahead and click it on top. It's just easier to see. So that's this input bar up here. The next thing, toolbar, make sure it says Show. And instead of having it on top, we're going to go ahead and put it on the left, just so it's kind of out of our way and it's easier to see there. From there, we're going to go to Options and click Save Settings. So again, Options, Save Settings. That'll make sure that every time we open this, it kind of looks the same. You might not have these grid lines in the background. It doesn't make a difference either way, so don't worry about those. So now that we have GeoGebra set up, we can go ahead and go back here and work on some of these problems. Alright, so for our first questions here, we're given a bunch of data. So we have their scores on math tests in each quarter of the year, and we're going to create a dot plot for each one, and we're going to kind of see how it looks. So doing a dot plot by hand, kind of annoying, but what's nice if you're going to use GeoGebra like I'm going to show you is it'll do all of the work for you. So we're just going to do one example here. We'll just work with Sierra's scores. So what I'm going to do is type all of this data into GeoGebra. Okay, so looking at those, notice I'm going to type everything in column A. The order doesn't matter. I'm just going to go down. So I'm going to go in this order, just kind of following down each one in order to put that data in. So looking at Sierra's scores, we have 88, enter, 94, 91, 92, 90, 86, 90, So let's say we typed in all our data there for Sierra scores. Now to create a dot plot for this, all we have to do is highlight our data. So notice I'm not doing this little drag down box. That's going to kind of copy everything and make it the same. So just left click up here and then drag down that way. So our numbers didn't change or anything. What we're going to do next is click this little histogram looking thingy, the bar chart here, which says one variable analysis. If yours is something different, that's fine. You can just click this little drop down menu and it'll give you all the choices. So one variable analysis, you already highlighted your data so it knows where to look, just press analyze. Now what this is going to do is going to be one of our biggest tools for this whole thing. So this will pop up, yours should look exactly the same, or yours might be a little different depending where this is at. But what this does is lets me kind of adjust how many bins or how many bars I'm going to get in here. Now if I want to go ahead and take a look at some different things, so we wanted to, say I wanted to find the statistics for this. I would click this little button here. It's got this looking E with an X, that's sigma, that stands for summation. If you highlight over, it says show statistics. You can click on that. We'll get more into this later, but these are going to be all the calculations you actually need for this whole unit. So very important on how to find that. So again, always have that highlighted. Next thing here, it wanted us to do a dot plot. So instead of doing this by hand, if I click here, wrong button, here, where it says histogram, go ahead and click down. And we want a dot plot, well let's go choose dot plot. So again, I clicked here, dot plot. Boom, there it is. So if this was a test question, you would just be able to kind of recreate this by hand. So I would just kind of draw the exact same number line. So when you're completing your notes on paper, you would just write down this number line and place your dots accordingly. Basically it's saying, like here for 88, I have 1, 2, 3 numbers that all lined up with 88. If I looked here in the middle, so between 90 and 92 is 91, it would look like I have 1, 2, 3, 4 numbers all at 91. So notice they kind of spaced out the dots evenly here. It doesn't have to be that big of a space when you draw it, but it helps you count how many are in each section. Alright, so getting back to our notes here, if we go ahead and take a look what they want us to find. So that was Sierra's. Like I said, we're going to skip over JC's, but the key idea is what type of distribution is this? So is it skewed? Is it normal? So as I'm looking here, if I think about kind of drawing a curve over this, it's got that nice hill shape. So this is going to be symmetric or normal data. If all my dots seem to be on the right side, it would be skewed to the left. If all my dots were on the left side, it would be skewed to the right. So when you're asked what type of distribution, that's kind of our go-to way to answer those questions. For deleting data in here, what you want to do is go ahead and just highlight it all and then press delete. I lied, press backspace. You press backspace, it'll get rid of all. Or you could just delete them one at a time. The key idea there is every time you do a problem, just clear it all out. It'll make sure you don't get confused with your data later on. Okay, at this point, we have concluded with notes 2, or number 2 on here in our ordering. So you should have these notes down, and then you will move on to number 3. Alright, so what we're working on here. We're going to do problems 1 and 2 together here. And then you guys are going to complete problems 3 and 4 for your practice. So, for problem 1, we're looking for mean, median, mode, median, and range. So to find these things, the first thing we're going to do is enter all of our data into GeoGebra. So just like before, I have everything cleared out, and I'm just going to type those numbers in going down. 35, 56, 34, 44, 52, 12, 34, and 45. Now, again, we're going to go back to those statistics, so I'm going to highlight it all. One variable analysis, analyze. Again, make sure you have this box clicked, otherwise you're not going to get all those numbers. Alright, so for the first one, we're looking for the mean. It's listed right here. The mean is 39. So we can go ahead and write that in. For our mean, it's going to be 39. The median. Well, right here, median. It's already calculated for us at 39.5. So median, 39.5. Now, mode is the number that occurs the most often. So if I have, for example, if I had the same number the most times, so let's say I look here again, 135, 56, 34, 44, 52, 12, 34 again, and 45. What we're thinking about here is which number shows up the most. So if I look, well, 34 shows up 2 times. So 34 would be my mode. Now let's say every number just showed up 1 time, then I would have no mode. So it is okay not to have a mode. Okay, range, that's our maximum minus our minimum. So if we look here, our max and our min are listed for us. So again, it's max minus min, which in our case here, the maximum is 56, minimum is 12. So it would be 56 minus 12, which will give me 44. So my range is 44. Looking at question 2 now. So again, notice I'm going to delete everything in here. So I'll get rid of this. I'm going to highlight all my data, hit backspace. You can hit twice for some reason, but it gets rid of it. So I'm going to type in all that data for number 2 now. Alright, same thing, highlight, one variable analysis, go. And here we go. So our mean, 31. Our median is at 32. My mode, if I looked at that data, well, it's not looking like any of those numbers show up twice. So that'd be an example where we have no mode. For the range, max minus min, so 45 minus 16. Get our answer there. So, at this point, you should be good on our number 3 here. And you are going to head and complete number 3 and number 4 for your practice. So we already talked about number 2. You can write those answers in as well. But again, you are completing numbers 3 and 4 here for practice. If you follow your timeline, it's listed there, complete practice, parentheses, in 3, numbers 3 and 4. Alright, from here we're going to go ahead and move on to number 4. Alright, so here we're given a table. So we got to consider the weights of some of the starting lineup for the 2013 Big Ten Illini football team. So here's their names, their jersey numbers, and their weight in pounds. So, first couple pieces of information here should look really familiar from the day before, or your notes before. Mean, median, mode, and the range. So we're going to hop back into GeoGebra. Again, get rid of any of our data we might have here, and start typing in those weights. So 200. And 310. Alright, so we know how to highlight, right? So we're going to go ahead here. One variable analysis. And again, make sure you got this clicked. And we get all of our data here. So our mean is 233.5. So I'm just going to go ahead and write that here on my other screen. So I'm just kind of copying that data down. wrong number there. Our median, if I look down here, median 227.5. Our mode, if we look back at that list of data, let's see, okay, 200 only shows up once. Alright, so there's my median, my mean, and my median, and now I'm looking for my mode. 200, nah, it's only once. 295, only once. 250, only showing up once. 175, no. 235, no. 260, no. 195, 310, no. So we got none here. So this is another one where we got no mode. The range, that's our biggest minus the smallest. So our max here is at 310, min 175. So 310 minus 175. Another cool part about GeoGebra, it actually does a lot of these calculations for you. So if I want to do this without a calculator, X out of this, up here on my input, I can go ahead and type 310 minus 175, click enter, and in your algebra tab it'll pop up with the answer for you. So it gives me that 135. Ignore the A equals, it just names numbers things, but it does the math for us there. So our range is 135. You want to get used to using GeoGebra for every single bit of our calculations, because when you guys take tests, unless you have a calculator of your own, this is going to be the program you're going to use. And again, it'll do everything in an exceptional way for us. Okay, now, interquartile range. These steps listed here are actually how to do it by hand. We're going to go ahead and just use GeoGebra. So, first here, IQR is calculated with Q3 minus Q1. So if we look here at GeoGebra, we're going to have to bring this numbers back up. So highlight, variable analysis, analyze. So it's actually told already what it is here, Q3 and Q1. So Q3 is 260, Q1 is 195. So we have 260 minus 195. If we're going to pop back into GeoGebra, I can go ahead and do the math there. So back in my input bar, 260 minus 195. Boom. We get our answer here. Notice it highlights it for us from our most recent calculation is 65. So for my IQR, it's the distance between Q3 and Q1, and it's 65. I'm going to skip over that critical thinking box there. Alright, let's talk a little bit about outliers. So, an outlier is a value in the data set that is much bigger or much smaller than most of the other values in the set. So if I had the numbers between 1 and 10, like 100 would be an outlier, or negative 50, because those are way out of that range. Alright, so here, outliers are determined using the blank or blank. What we're actually going to use here to find this is going to be a bit of a shortcut. So to do this, what we're going to do is go back here, and let's do an example with our data. So these are the same Illini football weights. So if I click on these, I'm going to do my analysis, analyze. What we can actually look at to find outliers is what's known as a box plot. So if we go ahead and utilize our box plot here, it's going to kind of give us some information about this. So if we want to see what one with an outlier would look like, let's go ahead and add a number in here, like 500. So here, GeoGebra actually calculates outliers for you. So instead of using these formulas by hand, what we're going to do is look at box plots. So again, to get to that, I just clicked here, went to box plot. Now, anything that's an outlier is signified by one of these X's. So notice here we have a box plot, everything's kind of hanging out, and boom, I got one number that's way out on its own. So this is our way of calculating an outlier. So if there is an outlier, it'll show up as an X when you look at the box plot in GeoGebra. So without that 500, if we go back to here, let's get rid of that extraneous random number we put in. Kick it back. So again, go to my box plot. I got no X's. So in this data, there is no outliers. Again, if we've seen an X, it would be an outlier. So no, don't worry about this formula. We're not going to have to do that because we have GeoGebra. So in this one, no outliers. And again, we're thinking of those x's in GeoGebra. Alright, so here it's just kind of telling you, so your first question here is going to be to just go ahead and create a dot plot in GeoGebra, insert the dot plot below. What you can do there is, again, just kind of same thing we showed in the notes before. Go into GeoGebra, type your data in, create that dot plot. You don't need to insert it into this program, obviously. Just kind of write it down on paper, and again, know those steps. Here, you're going to calculate all your values. So again, this is all coming from this above data. So use the same data for questions 1, question 2. Don't worry about this one here, so we don't need to do the old... Actually, you know what? Nice thing about standard deviation, it comes in GeoGebra too. So standard deviation is this S. So when we calculate it, if I want standard deviation of this data, S stands for standard deviation. So just a reminder, when you do that, you're looking for S equals. Looking into number 3, these are the 3 problems you're doing here. For this one, what we're looking at again, just go to your box plot, so ignore these parts. So we don't need to do this. So here we're just going to look at the box plot. And again, that's as simple as saying yes or no. Is there? Do you see any x's? And then let's not worry so much about this question. Or this one. Basically, you're just telling me, is there an outlier? Yes or no. And that's just looking at that box. Alright, so from here, once you complete this, what you're going to do next is go on to 5. For 5, you're already given some information. Again, so we're just going to kind of go ahead and go through this, so you will complete all of the problems on this practice. Once you're done with that, again, check it in, make sure you take your time with it, and then we'll be moving on. So once you've completed that, the next thing you're going to go on to here is number 6. So notice we're not skipping around, we're going right in order. Alright, so we're going to go ahead and complete these notes together. So, for the first one here, we have a box and whisker plot. Helps to show how the key idea here is symmetric. So going back to our shape, so symmetric or skewed. So the opposite of symmetric is skewed, either that left or right there. The data are. The IQR is used to measure how blank the data points are in a set from the mean there. This is how spread out. So it kind of gives us a visual where all our data is. So the higher the IQR, data points are more spread out. The smaller, the data is more compact. So it says spread out. This one compact, meaning it's really close together. So visually here, this is our min, Q1, the median, Q3, and the max, or the maximum. Alright, so here we're given a dot plot already created. We've got a nice number line here. GeoGebra makes it within the bottom, but again, we can kind of see where things are. So, what we want to figure out here is how much is in each chunk. So between each of these, so between the min and Q1, there's going to be 1/4 or 25% of the data. Between Q1 and the median, we get another 1/4 or 25% of our data. And the same pattern kind of goes along here. So between each of these points, we get 1/4 or 1/4 or that 25% of our data. No matter what your box plot looks like, this rule is always going to remain true. So no matter how far out those lines look, these percentages or fractions of data remain the same. Alright, so part A, if all the watches under $31 are in clearance, then about what fraction of the watches are in clearance? Well, let's see, we're looking less than 31, so I'm looking here, well, this is my min, Q1, median, Q3, and my max. So, below 31, that's going this way, and that's one of those intervals. So, 1/4 or you could put 25%. Either way is fine. Now we're looking between 31 and 71. And what fraction of those are on sale? Well, 31 to 71, let's say I'm making 2 jumps, so 2 of those intervals. So if I doubled this, well, 1/4 plus 1/4 is 2/4, or 1/2. Now, or we could think of that as 25 plus 25 gives me 50%. So quick note on how to do fractions here in GeoGebra. So let's hop back into our program here. To do a fraction, I'm going to go up to the input bar. Now, this isn't a command. You guys can have note cards when you do tests. I don't expect you to memorize these things, but just so helpful stuff. So to do a fraction, we start typing fraction. And it's going to be this second one where it says fraction text. So you want to make sure you choose fraction text. And then here, we're going to go ahead and type in what we want. So let's say I want to do 1 divided by 4. So the divided by is a little slash symbol. Plus 1 divided by 4. So 1/4 plus 1/4. Press enter. And it shoots out our answer here, 1/2. So it does the math and it simplifies it for us. So 1/4 plus 1/4, I could say, or 1/2 of the data. Moving on down. Here we have average miles per gallon used in a city for driving a certain model of car. So we got our blue cars, our small ones there, and the green ones are the bigger ones, the sport utility vehicles. Alright, we're going to compare the number of small cars that get less than 25 miles per gallon with those that get more than 25. So we're looking at what percents in each. So if I'm looking at less than 25, that's going this way, so that's 2 jumps. So for my small, I have 50% of my data. And more than 25, let's see, even though it looks really big, I'm still only making 2 jumps. So for my bigger cars, it's still going to be 50% of my data, because it's all about how many of those intervals we have, not how long they look. About what fraction of the sport utility vehicles, so the green, get less than 14. So if I'm looking at 14 less, well, that's only 1 interval. So again, that's 25%, or we could think of 1/4. Conclusion comparing the 2 groups of vehicles. Well, one conclusion I could say, let's see, well, small cars has a much bigger range, like it's more spread out. So I could say the range of small cars is much bigger than that of sport utility vehicles. So small car range is bigger than a sport utility vehicle, so I'm just going to abbreviate SUV. Alright, and there we are going to be done with this practice. So we're done here with number 6. Now what you guys are doing for your practice is you're going to go on to number 7. So here you'll see you're given some very similar stuff. We already know how to create a box plot, right? We just go into GeoGebra. So look at GeoGebra, copy it down on paper. Here we're only looking at the weights, so make sure you only type in the weights. Don't worry about the heights, their names, or their numbers. For this stuff, we don't actually need any of this technically, because you're just going to create it in GeoGebra. So let's go no. Here you're going to have to go ahead and calculate this, so we are going to do step 5. And then this, again, we're just going to kind of draw it from what we see in GeoGebra. So for this whole problem, we're just rocking GeoGebra. Moving on down. Alright. Coming from here. Let's see, we don't need to do this by hand. So what we're going to find here for me is you're going to find the min, Q1, median, Q3, and our max. And this is all done with, you guessed it, GeoGebra. So don't worry about your tasks here. Just go ahead and use GeoGebra to go ahead and do tests to construct that box. Don't worry about this one. Or this. Let's see. We're going to skip this as well. So really only got like one problem on this page, so let's not worry about it too much. But go ahead and work through this now. So you're just working on these first like 2 problems here. Once you've completed it, we are going to go ahead and move on to number 8. So taking a look at notes 8 or number 8, what we're going to go ahead and do here is look through a little bit of some different stuff we're going to do with statistics. So we're going to go ahead and do this whole thing together. Alright, so step 1 here, we're looking at the normal distribution. So this is symmetric, everything's kind of in the middle. Alright, so 1 standard deviation. What a standard deviation means is one of these jumps. So what's found in the middle of each of these graphs is our mean. So I'm just going to call it x with a line on top, or you could write mean. Either way is fine. That is what's going to come up in our program later, our calculator, so x bar is just kind of the way we write the mean. So those things mean, well, those are synonymous terms. So mean, this is like the cool math symbol, x with a line on top. Okay, so a standard deviation means one of these jumps. And what we called this earlier, we found in our GeoGebra, is just labeled as S. So S stands for standard deviation. So 1 standard deviation means 1 jump in each direction. So 1 to the left, 1 to the right. And standard deviation is just a number we calculate. It deals with like breaking up data into percentages. So if I go 1 standard deviation each way, I got 68% of my data. So if I think about it symmetric, so that means 34 is in this interval and 34 is here. 2 standard deviations, so going 1 to 2 jumps in each direction, that gives me 95% in between those 2 numbers. So this is 34. These little ones are both 13.5. So 34, 34, 13.5, 13.5. Alright, last one, 3 in each direction. So 1, 2, 3, 1, 2, 3. That gives us 99.7%. So those percentages, 34, 13.5, 2.5. And on the tail end here, we'd have 0.15. So I'm just going to go ahead and draw that again so you guys can kind of see it. So this would be something you'd want to definitely have down. The number line, we're going to have our mean in the middle. 1, 2, 3 to the left, 1, 2, 3, or to the right, and then 3 to the left. So I'm having this thing, excuse my art skills, there you can see are not the best. So here's our mean. This is our middle of all the data. So in each of these jumps, going in this direction, we have 34%, 13.5%, 2.35%, and on this little tail end, there's going to be 0.15%. It's symmetric, so going in the opposite direction. If this is our mean, our middle number, it's going to be the same way going this way. So again, this is definitely like a note card item. You don't want to forget those, but don't necessarily need to memorize it. So moving on down here, example 1. Given the mean and standard deviation, find all the values between -3 and +3 standard deviations from the mean. So what we're going to do is go ahead and label this thing. Also, here's another nice version of those percents. They just don't have the 0.15 on the sides. Okay, so mean is 48. That's going to be our middle number. So here, 48 goes in the middle. Now, standard deviation is the distance in each jump. So what I'm going to do here is add 2.5 to get the next number to the right. So in GeoGebra, we're starting with 48 and adding 2.5. So 48 plus 2.5 highlights my answer at 50.5. Also, you can delete this stuff anytime. If you just right-click on it, delete. Right-click, delete. It kind of helps to get rid of stuff after you use it. So that 48 plus 5, 50.5. And you could again add again to get our next one here. So 50.5 plus 2.5. And for my next one, it would be that 53 plus 2.5. So for my numbers, now that was going to the right. To go to the left, we're going to subtract, because numbers get smaller to the left and bigger to the right. So this time I'm going to subtract 2.5 each time. So I'm going to go ahead and delete here, right click, delete. So 48 minus 2.5. 45.5 minus 2.5. And 43 minus 2.5. So I get 45.5, 43. And the last one there was 40.5. Now, to answer these questions, what is the interval between 68% of data? So 68 means going one jump each way. So that's between 45.5 and 50.5. 95%, two jumps each way. So 1, 2, 1, 2. So that's between 43 and 53. 99.7, that's going all the way to each end, 3 jumps. So 40.5 and 55.5. And again, not necessarily something you need to memorize. You guys can have that on a note card. It's just knowing how to answer those questions. Example 2 here is going to be pretty much the exact same thing, so just kind of refer again to example 1 here. Example 3, same exact thing. We got decimals, don't make a difference. We're doing the problem the exact same way. Here, again, same exact thing. Alright, so let's go ahead and take a look down here. So for this one, we have Aaliyah scored a 95 in her last test, which is exactly 3 standard deviations above the mean of her class. The standard deviation was 4. What was the mean grade on the test for the class? Alright, so first thing, we know what Aaliyah scored, and we know how many standard deviations. So let's go ahead and draw out our picture here. So we'll just go with a number line. We don't need to draw the curve. You can, but don't make a difference. So our middle is our mean. So I'm just going to go ahead and call that the mean. And then I know I have 3 going in each direction. This is kind of the go-to number line for all of these problems. Alright, so let's see what we know here. Aaliyah scored a 95, and she was exactly 3 standard deviations above. So 1, 2, 3. So here's her 95. That's our person here, Aaliyah. I read on. I find out the standard deviation. So our S is 4. And we're trying to figure out what is the mean. So what is that middle number? Well, what I know is that since my standard deviation is 4, that tells me that each one of these jumps, or each one of these lines here, the intervals, these all have a length of 4. Even though my drawing is not perfect, they all have a length of 4. So to go from a number on the right to the left, I'm going to subtract 4 1, 2, 3 times. So 95 minus 4 minus 4 minus 4. Pops out my answer here at 83. So the mean is equal to 95 minus 4 minus 4 minus 4, which gave us 83. Number 2, we got Richard, scored an 88 on his last quiz, which was exactly 2 standard deviations below the mean. Standard deviation was 2. What was the mean grade? So again, we're going to go ahead and draw up that number line. Mean in the middle. 1, 2, 3. 1, 2, 3. I kind of make the mean line a bit longer just so I can see it's the middle. Okay, so Richard scored an 88. 2 standard deviations below. So 1, 2 below, that's 88. That's Richard down here. And it tells me the standard deviation was 2. So this time, each one of these jumps represents 2. And again, we're figuring out what does that mean. So since I'm going to the right, instead of subtracting up here when we went down or to the left, we're going to add 2 each time. So the mean for this one is 88 plus 2 plus 2 again. Check in your Algebra, you should find 92. Here, We have Melissa scored 92 on our last test, 1 standard deviation above the mean. Standard deviation of 5, and yet again we're figuring out that mean. So here's my mean, again kind of drawing that longer line. 1, 2, 3. 1, 2, 3. She had a 92, 1 standard deviation above, so 1 above 92. And just like we've seen these first ones, my standard deviation was 5, so this jump here is representative of 5. So to figure out that mean this time, it'd be 92, and we're going to the left to get to the mean, so I'm going to subtract 5. Checking in GeoGebra, we should get 87. Number 4, we're going to kind of skip over here, pretty similar to everything else we've done. And again, this one, number 5, same thing, kind of find the mean. So examples 1, 2, and 3 there should be all that you need to do those problems. At this point, when we're done here with 8, we're going to go ahead and move on. Numbers 9 and number 10 are going to be practice. So you need to complete all those problems. So we'll walk through those real quick just to make sure we know what we're doing. Alright, so for number 9, here you're just kind of labeling what things are in the picture, so just helping you remember where they are. And then you're going to go ahead and find the standard deviation. So the standard deviation represents the distance between these. So here I do 82 minus 75. That would tell me how far apart they were. These are working through problems like we did before, so you're doing all of this page. Number 10, here's just kind of finding things, so knowing that the mean is in the middle. Standard deviation is the distance between the two numbers, so for this one I would do 26 minus 17, or here 59 minus 54. And these problems, very, very similar to what we've seen in our practice and our notes. So you'll complete all of 9 and 10. Once you have done so, you're going to go ahead and move on to 11 for some more notes. Alright. So now we're going to work on problems 1 and 2 together. Here it says use a graphing calculator. Hint, we're going to still use GeoGebra. So, going from this picture to what we're going to type in GeoGebra. So this is what's known as a frequency histogram. So the bottom tells me a grade, and these little lines here tell me how many people got that. Or again, they're labeled on top. So let's go ahead and do 2 of these questions together. So first thing I'm going to do is get back into GeoGebra. I'm going to get rid of anything I have in here just so I don't get confused. Alright, so typing in our numbers. If we look at this picture, it shows me I have 1 84. I have 2 85s, 3 86s, and so on. So I'm going to type each of those in here. So I have 184, 2 different 85s, 3 86s, 4 87s, 3 88s, 2 89s, and a single 90. So, having typed those in, we know we're going to need our statistics, so let's go ahead and highlight and pull that data out. So, analyze, boom. Statistics is highlighted, and I get my answers. So let's go ahead now and use that to answer our questions. So the mean, we can see labeled there as mean is 87. The median going down, that one also happens to be 87. Not necessarily always going to be like that, but here it is. Standard deviation, we're using that S. So S for my standard deviation, 1.633. Quartile 1 is listed as Q1 on there, it's 86. Q3, listed as Q3, is 88. Interquartile range, it's Q3 minus Q1, so that'd be 88 minus 86. Which gives me 2. Outliers. Well, when we want to find our outliers, that's where we go ahead and look at that box plot. So I'm going to click here on histogram, check my box plot. Do we see any X's? No. So is there outliers? Not in this one. Again, if we have an outlier, we see an X on either side. Outliers? None. And for box plot here, we're just going to kind of draw what we see in that GeoGebra. So I'm just going to kind of freehand what this would look like, probably a little easier on paper. So I draw my number line, so copying this, and then draw each of these lines in accordingly. Also shape here, so the first thing, again, it kind of follows that hill shape, so this would be, you could write normal, or you could write symmetric, or hill, any of those work for me. So, what you guys are going to go ahead and work on here in your practice is the rest of these problems. So you're going to do numbers 2, 3, 4, and 5. And 6, sorry. Got there with 6. So we're going to go ahead and skip over these ones down here. You don't need to worry about these. So don't worry about the investigations. You guys are just working on numbers. Actually, you know what? We can skip 2 as well. Let's just do 3, 4, 5, 6. So let's not worry about 2. Just do numbers 3, 4, 5, and 6. So those are the ones you're doing. Again, you can skip over all these things at the bottom here. Alright, moving on to our next set of notes here. Almost done with our whole unit. Alright, a little bit about histograms. So we have a diagram showing the connections between 2 or more qualitative data variables using only bars. So the key idea here, that's a bar graph. Bar graphs have gaps between them. Histograms, they don't. So from this bar graph, what does it represent? It looks like the favorite type of movie. So A, that's just the title. Favorite type of movie, how many people kind of voted for it. How many chose sci-fi? Sci-fi, 4. Romance, 6. And let's not worry about part D here. Again, it could just be how many people chose a certain movie. So that was a bar graph because there's spaces. This is our categorical or qualitative data. Histograms, they work with strictly quantitative data, so that numbers. So let's see here. To represent this histogram as a table, first we're going to break up our ages. So this is between 1 and 10. I'm just getting these from the bottom here, ages. So just copying down each of those intervals there. Okay, frequency, that's the number in each. So here in this interval I have 25. This one looks like about 10. Here, 20. It's between 30 and 35. So I'd be with a variety of answers here. It looks like maybe 34 of me. If you put 33, 32, 35, as long as it's close and it makes sense, you're good. This last one here looks like a little less than 10, so let's call it 9. And here I'm pretty close to 5, so we'll go with 5 there. Alright. Which age group were there most of? Well, that's the biggest one, so that's 31 to 34 years. Or 31 to 40, my apologies. How many people saw the film together? Well, that would be adding all of the frequencies up, because that's the total number of people that's seen it. So if I added these numbers, I'm just going to use GeoGebra here. So adding some stuff up. I'm doing all my frequencies, so 25 plus 10 plus 20 plus 34 plus 9 plus 5. So again, you can type it all at once in GeoGebra. Boom. So you had about 103 people. So how many people saw the film? 103. Were there more people over 30 or under 30? Well, this line here looks like this is my over or under 30. So if I'm adding up the numbers to the left, those frequencies, it would be 25 plus 10 plus 20. So for my under 30, so to the left, I'd have 25 plus 10 plus 20, which would give me 55. And my over would be all these three. So 34 plus 9 plus 5, let's say it's going to give me 48. I lied. 58. Let's see, 39 plus 9, yes, 48. So we only had 48 people in the over. So this one would be under 30, because that's the age group where there's more people from. Which age group were there the least of? Well, we look at our frequencies here. This last one, 51 to 60, that had the least number of people. So the smallest bar, or the least in frequency. Alright, you guys are going to love this. Creating a histogram. Guess what we're going to use? GeoGebra. So, if we want to go ahead and create it from this data, popping back into GeoGebra, let's get rid of all our stuff so we don't get confused. Alright. So I'm just going to type in each of these numbers. You don't got to put it in order because GeoGebra does that for us. So I have 5, 4, 3, 6, 1, 9, 3. Even if there's a 0, you do have to put it in. It's still a data point. So even though it's technically none, make sure you always put, if you have a 0, put in the 0. Alright, so let's check out our histogram here. We're going to highlight, same steps, one variable analysis. And it's that one that's been popping up all day. Our first one here at a histogram. Quick point of things, so it says here that arrange the equal intervals. It already does that for us. So what we can do here is on this, you would just kind of draw whatever you have down here. So this is set at 5. I am 100% fine with you leaving it at 5 classes. That just says how many bars there are. So you're welcome to do more, it just kind of gets uglier looking. Same if you only do like 3, it's not too pretty. So let's always use 5 for our number of classes. So you would just basically take this, draw everything. So draw your y-axis, your x-axis, and recreate this image on paper. Alright, that finishes up our notes 12 there. So I just realized I did the practice with you. So I went ahead and did this with us. So that kind of knocks off both those bubbles for your completing your notes 12 first page and your practice of 12 that second page. So we're good there. The last thing for this unit, if you're following your timeline, is you're going to complete this entire review. So you're going to go through the review, make sure you check this in with me. If you can do all these problems, your test is going to be so easy for you. Again, it's going to match up very well. So once you've completed the exam review, the last thing you got to do to be done with your Unit 1 is go ahead and we're going to pass that Unit 1 exam. So again, best of luck. You can rewatch this video as many times as you need and ask questions when you have them.